Good morning, friends. Today I will explain you chemical properties of the benzene. Benzene is the parent compound of the organic chemistry, that is aromatic compounds. Its formula is C6H6 and it is a cyclic compound with three alternate bonds and it is delocalized by bond and resonance like these structures. It is very reactive and the stable compound because it contains three alternate double bonds and it exists in the resonance form, which gives it more stability. Now, due to the presence of the alternate double bond, it gives mainly substitution reactions. Addition reactions at very high pressure and the temperature, and then oxidation reactions. If we talk about the benzene, this double bond is there, but like alkanes, it does not dechlorize the bromine water in CmO4 and the alkaline CmO4. But addition reactions at high pressure and the high temperature. Now I will explain you some substitution reactions and their mechanism. First, I will take an example of the halogenation. Halogenation means replacement of the hydrogen from the benzene by halogens, that is chlorine, bromine and the iodine, in the presence of a catalyst, that is anhydrous aluminum chloride or the ferric chloride. Simply, substitution of the hydrogen takes place and chlorobenzene is formed. But actually, it seems to be a simple reaction, but it is not a simple reaction. So, what is the mechanism for this reaction? How this chlorobenzene is formed? First, this aluminum chloride or the ferric chloride, which acts as a catalyst, it is a Lewis acid, means electron deficit. And this Lewis acid first polarized the chlorine atom to form the chlorinium ion, which is electrophile in nature. Listen here, it is electrophile in nature. So we say that this reaction is due to the electrophile, that is a here chloronium ion is formed. So the point is that here ferric chloride, aluminum chloride is a catalyst and it is a Lewis acid. Lewis acid means electron deficit in nature. Now this electron deficit in nature Lewis acids polarize the chlorine molecule to form the chloronium ion, which is electrophile in nature. Now this electrophile chloronium ion attacks the benzene and forms a intermediate compound, that is a carbocation. And this carbocation then gives out the proton to the ferric chloride, that is negative charge, to form the ferric chloride and HCl, and chlorobenzene is formed. A very important thing is that during the formation of the carbocation, this alternate three bonds breaks, and then finally again when the proton is removed, again it regains the chlorobenzene nature, that is the three alternate bonds are again formed. So this is the mechanism for the substitution reactions. Here actually this catalyst is just to produce the electrophile, that is Lewis acid, which is deficit of the electron. It polarizes the chlorine molecule to form the chloronium ion, which is electrophile, and then the hydrogen ion is substituted to form the chlorobenzene. Now we see the second substitution reaction, that is nitration. Nitration means replacement of the hydrogen by a nitro group. In a simple reaction, if you say benzene is heated at about 330 K with nitric acid in the presence of the concentrated sulfuric acid, nitrobenzene is formed and water is formed. Now again here, what is the mechanism? How this nitrobenzene is formed? Here again, if you see concentrated sulfuric acid, it releases hydrogen proton and then nitric acid forms a protonated nitric acid which converts into the nitronium ion, which is again electrophile in nature. See, sulfuric acid gives hydrogen and H2SO4. This hydrogen ion forms with nitric acid, that is, this hydrogen ion goes to the one of the lone pair of the oxygen to form the protonated nitric acid. It breaks and forms the nitronium ion, which is again electrophile in nature. So the point is that in the substitution reactions, electrophile, what is very important? This electrophile reacts with benzene to form an intermediate carbocation. Just like this, carbocation. So this electrophile, that is the nitronium ion, react with benzene, break with arterial double bonds to form the intermediate carbocation. And this intermediate carbocation again gives out the proton to form the sulfuric acid and nitrobenzene is formed. So, in the case of the substitution reactions, a very important role is of the electrophile. So, electrophiles are the deficits ions of the electron. Here, function of the aluminum chloride, that is the catalyst, and here, function of the sulfuric acid, concentrated sulfuric acid, is to generate the electrophile which take part in the reaction. So I think it is clear to you how the substitution reaction takes place in the benzenes. Now in my next video I will continue the different reactions, more example of the substitution reactions, then addition and the oxidation reactions. Okay, if you like my videos, please share and subscribe. Thanks very much.